Release the Kraken!
Welcome back, fellow game designers. And in this one, ladies and gentlemen, the one we've all been waiting for, how to place blocks into our scene. So that's what we're going to do today, is place blocks into our scene. So we need two things. One, we need a block to place, and two, we need a bunch of math. So hopefully you don't turn pale. So I'm going to go to blocks here. You can see we do not have a block to place yet. Make sure that we have our static mesh block in, which we do. Go up to our blueprint block, and then right click, get a blueprint class, and then we're going to choose the actor class. We're going to call this block. Open it up. Inside here, we are going to do a little bit of fancy work. Come up to add component, and I'm going to come down to static mesh. And we are going to call this block. And then for our block, we're going to add this to our default scene root. So just click it and drag it. And we want this to be the scene root. Hey. Now we don't currently see anything, but that's because we have not yet loaded our block. So make sure you grab your block, and then come over to the right here, hit the drop down, and load your block. There it is. Compile it, save it, and that's pretty much it on the block. Now we need to go to our player controller. So go ahead and go into System, Player Controller. We have our basic movement. This is all well and good, but now we need a way of placing a block. So I'm going to come on down, find an empty spot, and we need to do a custom event. So custom event. I'm going to call this one get place location. So what we're going to do here is we're going to do a little bit of math to figure out where it is we can place our block. So off of here, we're going to do a line trace by channel. And there it is. And for our line trace, we need to know where our player is in the world and some distance ahead of our player that we're going to look so that we can scan to see if it's okay to place a block. So I need our player reference, get him, and we're also going to get its location, so get actor location. I'm going to take our actor location, plug it into start, and now we want to get our forward vector, but we don't want the one from our player because our camera can look in different directions, so we want to actually get the forward vector from our camera. So drag off of here, and then get FP camera, which is going to be all the way down here. And from our camera, we're going to get forward vector. Okay, so this is going to get the front of our camera based on the angle that it is looking at. From here, we are going to get our end location. So our ending location is going to be our character's position plus which is going to be a vector plus vector, so context sensitive. So our current location plus our camera forward vector times some distance. So this is going to be times a float. Plug this in. Plug this one in to the end. And then our distance is going to be our look at distance. I'm going to go ahead and drag this off. Promote to variable. I'll call this look at distance. Okay. And for now, I'm just going to head and put our look at distance in multiples of 64 because our block can only be placed 64 units ahead of us. Okay. So the shortest distance would be 64. The maximum distance is up to you in multiples of 64. So I'm going to do 128, which is 2 times 64. I do want to see this when I scan it, so I'm going to go ahead and add a debug for one frame. And then off of here, we want to check if we actually hit something. So off a return value, we're going to do a branch. And we also want to get our hit result. So break our hit result. Think. Okay, so if we hit something, we need to store some values. We need to know the location that we hit and the impact normal, and we also want the impact point at some point. So I'm going to take our location, do a promote to variable, plug this in. This is going to be look at location. So once we have our look at location, this is the location that our scan actually hit. We need to figure out a little bit of math and divide our world up into units of 64. So we're going to take this value, so get our look at location, and we're going to break this, so break vector. That's going to expose our x, y, and z. Now conversely, you can also split the pin. You're allowed to do this as well, but some people don't like this, so I'm just going to not do it that way. But it is the exact same thing. So we're going to open up our vector, get our x, y, and z, and we need to divide these by 64. So take that, I'm going to do a divide. Let's do this 3 times. Now I could just type in 64, but what if we want to change our block size at some point? So what we're going to do is, instead, I'm going to make a variable called block size. So drag off one of these, promote to variable. We're going to call this block size. And I'll plug that into each one of these. Our block size is going to be 64. So compile, and we can open this up. We'll do 64. Okay, that's going to return some value. And then we want to truncate that value. So what truncating does is it removes anything after the decimal, because we want a whole number. We don't want to divide our world into uneven values. If we do that, we'll get a block that's going to be off-center. So you can see how our grid here, we have these nice even grid lines. If we have a block that is in the middle, like this, where it's in between the lines, that would be bad for our game. So we want to make sure we're getting a very clean slice of the world. So off of this, we're going to do a truncate. And we need 3 of those. And now we're going to multiply back by our block size. So go ahead and drag off. We're going to do times float. So this is an integer value, which is a whole number, but we want to multiply it by a float. And do that 3 times. Plug it in, plug it in. And we're going to multiply it by the block size. Now you can use the same one and just plug it in. If that mess hurts you, you are also welcome to drag in a new block size and use this one instead. Whichever one of these works for your brain, it is the exact same thing. We're going to take the result of this and we're going to make a new vector. So off of this, we'll do a make vector. Plug in our x, y, z values. Okay. So now that we have this, we need to multiply it by the impact normal. So a normal, for those who are not familiar, if we come into Maya real quick and take this block, if I go up to mesh, if I go to display, and then come down to polygons and go down to face normals, you will see the normals appear as little hairs. on the end of the polygon. So let me go ahead and make these a little bit longer. Normal size. Let's make this so it's easy to see. There it is. Okay, so you can see this little hair that's kind of sticking off the face of a polygon. So this determines the side and the direction of this particular face. So if we hit this with our scan and we get the normal, it's going to tell us which direction our face is facing, which is going to be very important when I want to attach a block here or there or whichever. So that's how the normal works, but we can't just get the location and place it there. And the reason for that is we exported our block in the center, which means that the pivot point, if I go ahead and activate this, is also in the center. Which means that our block isn't exactly 64. Our block, if you think about it, it's 64 all the way across. But when we try to place this, it's actually going to place it halfway through. So if I take this block, for example, and I snap it to where it would actually appear, it would appear part of the way through our object, which is not what we want. So what we want to do is have it so that we get the location of the impact, we have the direction, but then we add the additional distance to it so it lines up perfectly. To do that, we're going to take our impact normal and we're going to multiply that by a float. And the float we're going to multiply by is actually going to be our block size. But we can't multiply by our entire block size because that would be 64 times the impact normal, which is not what we want. We want to take half of this. So we're going to divide. And we're going to divide our block size by 2. I know it's a magic number, but this will never change, so that's fine. So our impact normal is going to be multiplied by half of our block size. And the nice thing about doing it like this is if you ever change your block size to something bigger or smaller, it'll always run the same formula. I'm going to take this, move this over here, and I will just bend this around to make it cleaner. And now we can add this back to our location. So go ahead and drag this out. We're going to add vector to vector. And then the result of this is going to be our place location. So go ahead and drag that out. And we'll do promote to variable. And this will be called place location. Because this is where we can place the block. Go ahead and bring this up and drag this one to connect. And at this point, we can technically place a block. We do need to have a function for placing it though. So let's go ahead and make that. So down here, make a new function called custom event. We're going to call this one place block. So now we need to do a spawn actor from class. So spawn actor from class. The actor we're going to spawn will be our block. And then the transform, go ahead and open this up. We want to bring in our place location, and that's going to go into our spawn location. So now we have these functions, but we need to run them. So we're going to run this one, our get place location. This is going to go off of our event tick. So let me find a good spot, bring that up. Anything else run tick? No. Alright, so I'm going to come up here. Right click, let's get our event tick. Our event tick is going to run our get place location. So this is always going to be running. And then we're going to use our primary action, so primary action. Get our player reference. Let's make sure our player is valid. So is valid. And if our player is valid, we are going to place block. Okay. And we should also do this is valid check over here. That way we don't have to, if our player dies or something, this isn't firing and screaming at us. So make a little bit of room here. Borrow this is valid. Plug it in, plug in our player reference, and then plug in our is valid. There. Okay, so now I can see a little red line, and wherever this little red line is, you can see where it makes a contact point, and if I click, it places a block. Doesn't quite reach. It's also placing a block underneath. Alright, so I'm going to go ahead and call the video here, and the next one we'll go over refining our block placement and some minor level adjustments. Okay, stay tuned, and I shall see you next time. Hey guys, thanks for checking out my channel. Misty and I both thank you. If you've enjoyed that video you just watched, make sure you hit that like button and subscribe. Also, if you'd like to support the channel, I do have official merch and a Patreon somewhere in the link down below. Also, keep your eye out for the devlogs for Blockout and Rocket Flip. Those are 2 games that are coming out for Lame Duck Studios, officially released and all that good stuff. And if you guys want to see how those are being put together and the process that I'll be going through, stay tuned for that. You'll be seeing those coming up here soon. And don't forget that I create new content on Sundays and I release content on Wednesdays. So stay tuned, and I shall see you next time.